This is day 7 of Unit 5. We started today with a warm-up. So pause the video, try the warm-up, and then play to check your answers. Okay, I'm going to start with actually number 2 first. So how many real roots, how many complex roots? So remember, we count the x-intercept. So 1, 2, 3, 4. This has 4 real roots. Get a pen here. And this u right here makes 2 complex. And so when I add the 4 and the 2, I get 6 is the minimum degree. Or I can count the directions 1, 2, 3, 4, 5, 6. That's another way to get the 6. Okay, B, same thing. So I have 1, 2, 3 spots that the graph is touching the x-axis or going through. So there are 3 real roots. I have this U shape here, so that's 2 complex. So then I can count the directions 1, 2, 3, 4, 5, 6, 7. So 7 is the minimum degree. Or I can add up the real and complex roots, but when I do that, I have to count the doubles as 2. So 1 double, 2, another double, 4, a single 5, and then the 2 complex 6, 7. So 7 is the minimum degree. Number 1 I do have on the next slide. So there's your answer for number 1. So take time to check that. Okay, moving on. So today's lesson, we started with some problems here that were similar to what was on the bottom of page 13. If you had trouble with those in the homework after today's lesson, you should be able to go back and fix those and do a little better with them now that we've gone over it. So the first 2, my suggestion is to just draw yourself a sketch. So x squared minus 2, I know that's a positive orientation parabola shifted down 2. And this is just a quick sketch, so I'm not trying to make my x-intercepts perfect or my vertical stretch or compression or anything. I'm just shifting it down 2. So I can see that the graph crosses the x-axis twice, which means it has real roots. Next one, same thing. So right 3, up 1 takes me here for the vertex, positive orientation because of the positive sign. So we know it looks like that. So that tells us there are 2 complex. Actually, I didn't ask how many, I just said real or complex. So complex. Why? Because it's not crossing the x-axis. Here, I can't do a quick sketch because it's in standard form, so I could put it in vertex form by completing the square if I wanted to, or I could just find the discriminant. If you recall, the discriminant is b squared minus 4ac. That's the value underneath the square root in the quadratic formula. And remember, the discriminant tells us whether the solutions are real or complex. So we're going to figure out what b squared minus 4ac equals, and that'll tell us whether the roots are real or complex. So b squared is negative 3 squared minus 4 times a is 1 times c is 4. So negative 3 squared is 9, minus 4 times 1 times 4 is minus 16. So negative 7, that's negative. So remember, when the discriminant's negative, that means there are complex. So that's probably the quickest way to determine real or complex. Sketch if you can, or discriminant if it's in standard form. The other option would be to put 0 in for y and then solve for x. That would probably take a little bit more work though. Okay, next we worked on page 14, and 14 is about circles. You did a little bit of work with circles in geometry. So we start with this equation, and we're supposed to fill in the table. Well, if I think about that, the very first value is negative 3. So if I substitute in negative 3 for x, square it, I get 9. Well, 9 plus 0 has to give me 9. So that means y is 0. Similarly, down a little bit on the table, there's 3. 3 squared is 9. Same thing, y has to be 0. Now, we're not able to fill in all those values by hand, but we can fill in 0. If x is 0, 0 squared, then y squared has to be equal to 9, which means that y has to be equal to either 3 or negative 3. So if you graph those 4 points on the coordinate plane, so 3, 0, negative 3, 0, 0, negative 3, and 0, 3, you will get the graph of a circle. Okay, so do your best to draw a circle. And then just label those 4 points. Those are the important points. Okay, so this is a circle with a center at 0, 0 and a radius of 3. You can tell that by looking at the graph. So go ahead and fill in the center, the domain, the range, and function or not. Hopefully you realize this is not a function, fails the vertical line test. And domain and range are both negative 3 to positive 3 for both the domain and the range. Okay, so the general equation in what we call graphing form is that. That is graphing form, the general equation. So that is where h, k is the center, and r is the radius. So looking at our equation, we can see that h and k are 0 and 0, and r would be 3, which is exactly what we figured out a moment ago. So then if I want to find the equation for a circle with a radius of 5 and a center at negative 2, 4, I'm going to substitute the information into our general equation. And I'm going to get x plus 2, the quantity squared, plus y minus 4, the quantity squared, equals 25, or 5 squared. So that would be your answer for the question at the bottom of page 14. Okay, so that takes care of page 14. The only thing we didn't do there was filling in the table, and actually I guess we can briefly talk about that. So if I take my equation, x squared plus y squared equals 9, and I solve that for y, and the reason I'm doing that is so that I can enter this in the graphing calculator. If I want to solve this for y, I'm first going to get rid of that x squared, so I'm going to subtract x squared from both sides. Then we need to undo squaring, so I need to take the square root of both sides. We know the square root of y squared is the absolute value of y. This, be careful, you cannot simplify that. You have to leave it as the square root of 9 minus x squared. Common mistake would be to say that's 3 minus x. You cannot do that. If you do that, you're changing a circle into a line, and you don't want to change it into a line. It's a circle. So we keep it as the square root of 9 minus x squared. The way you can remember that, whenever you have an expression underneath a radical, a square root, and it's being added or subtracted, the adding or the subtracting is like glue. It's gluing those two pieces together. You cannot break them apart. So I leave that alone. Lastly, I'm going to get rid of the absolute value by making my answer plus or minus. So that is my equation in y equals form. Now, the reason that's helpful is because I can go into my calculator, into y1 and into y2, and I'll type in the square root of 9 minus x squared for y1, and then negative the square root of 9 minus x squared for y2. And I'll graph both. And when I graph the positive square root, I'll get the top half of the circle. And when I graph the negative square root, I'll get the bottom half of the circle. And that's how you have to type it in the graphing calculator. There's no way of entering plus or minus at the same time, so you have to enter them separately. But anyway, once you enter that into your graphing calculator, you'll be able to fill in the rest of that table on page 14. Okay. So we're going to do some more where we're solving for y, getting y by itself, similar to what we just did. So I'm first going to subtract x squared. Next, I'm going to take the square root of each side. I get the absolute value on the left. I cannot simplify on the right. I leave it alone. Okay, be very careful. You don't want to turn a circle into a line. I get rid of the absolute value. And last, I subtract 1. And that's my equation in y equals form. So once again, if I wanted to enter that in the calculator, I would enter it as 2 separate equations. Next one, same idea. We're going to subtract the x minus 3 quantity squared first. Now we can take the square root of both sides. We end up with the absolute value of y minus 9. I leave this alone. I can't simplify it. So next, I remove the absolute value. And I add 9. And now I have the equation solved for y. Okay, next, go ahead and get those 2 problems in your notebook. So we want to put these in graphing form. And remember, graphing form, I told you a minute ago, looks like that. So that's our goal. We want it to look like that. So if you look at that, basically I'm going from what's kind of similar with parabolas to standard form, and I want to get that into what's similar with parabolas to vertex form or graphing form. So the way that we did that, if you recall, was we completed the square. That's exactly what we're going to do here. We're going to complete the square to get this into graphing form. So I'm going to group the x's, skip a little space after my parentheses, plus sign, group the y's, skip a little space, and equals -2. So if you remember, I'm going to complete the square by taking half of the b and squaring it. So -2 squared gives me +4. I just added 4, so I have to subtract 4. Half of 6 gives me 3, squared is 9. Subtract the 9. And next, we're going to rewrite this as a binomial squared. So that would be x minus 2, the quantity squared. Same thing with this trinomial, rewrite it as a binomial squared. That's y plus 3 squared. Okay, so now if we compare this to what we want, we're almost there. Something squared, something squared. We just need to get these numbers on the other side. So we're going to combine -4 and -9 to get -13, and I'm going to add 13 to both sides. So when I add 13 to -2, I get 11. There's my equation in graphing form. Okay, and we should be able to look at that in graphing form and know that the radius is the square root of 11, and the center is 2, -3. Next one, same idea. So why don't you try this one? Pause the video and try it. So I'm going to group the x's. Group the y's. So half of 10 is 5 squared is 25. Subtract 25. Half of -8 is -4 squared is 16. Subtract 16. Rewrite as a binomial squared, x plus 5, the quantity squared. Binomial squared, y minus 4. Combine the -25 and -16 to get -41. Add 41 to both sides. And 41 plus 10 gives us 51. So there's our equation in graphing form. Again, you could look at that and realize the radius is the square root of 51. and the center is -5 and +4. Okay, and that's it. So your homework for tonight, you're going to go back to page 13. You're going to try those problems at the bottom again. Hopefully they'll make more sense now. And then I think we did all of 14 except for maybe filling in the table. You should do that. Practice trying putting the equations for circles in a calculator. And then you're going to do all of page 15. So 15, finish up 13, and finish up 14 by typing the circle equation in your graphing calculator and looking at the table. Okay, do those for tomorrow.